Okay, so here we're asked to find theta, and we have a trig function, sine of theta equals negative 0.4356. So your first thought is to use the inverse function. So if we were just simply to do that, we would say theta equals sine inverse of negative 0.4356. And then just simply using a calculator, typing that in, we get negative, so theta is approximately, go straight out of the calculator, negative 25.8 degrees. I'm in degree mode. But the problem here asks to find the angle in quadrant 3. And certainly an angle of negative 25 degrees doesn't terminate in quadrant 3. Okay, so as you'll notice when you're doing these trig functions, simply taking sine inverse, cosine inverse, tangent inverse of whatever they give you doesn't always work. Okay, so what I'm going to do is I'm going to show you how to work through the reference angle theorem. Okay, so in this case, you always want to take sine inverse of the absolute value. Now, if you do that, you're always guaranteed the reference angle. And we denote that with theta with a little hat above it. So that's theta hat. So the reference angle is going to be equal to sine inverse of the absolute value of that ratio. So 0.4356. Now, when I do that on a calculator, I get 25.8 degrees. So theta hat, the reference angle, is approximately 25.8 degrees, rounded off to 1 decimal place. Now they wanted us to figure out the angle that's going to give us that ratio in Q3. So Q3 is over here. All right, and so what we'll do is just sort of draw an angle in standard position here. And so this is the angle we're after, so that's the theta I want. Now the calculator gave me that reference angle, okay? So that reference angle is the positive acute angle made with the x-axis. So that's this guy. Calculator gave me this answer, or that angle. Okay, so knowing that angle, I want actually theta. So theta, you can see here, is the straight angle, 180 degrees, plus that little bit. So the theta that I'm after is going to be 180 degrees plus that particular reference angle. Right? So that'll get me terminating in Q3. So in this case, we have 180 degrees plus 25.8 degrees. So theta is approximately equal to 205.8 degrees. All right, and so that definitely terminates in Q3. Now we can always check our answers with these by plugging into the original, right? So we have the check. Now it's not going to be exactly the same because we did round off, right? This is an approximation. But on a calculator, we can always check by taking sine of the angle that we think is the answer, right? And seeing that it's at least close to the original negative 0.4356. And you can see here it is. So negative 0.4352. So we are off by that round off error there, but that's pretty much it. Always take sine inverse, cosine inverse, tangent inverse of the absolute value of the ratio, and you're guaranteed the reference angle. Let's do another one. All right, so here we have cosine theta equals negative 0.7612. We're asked to find theta, terminating in quadrant 2 this time. Now, I know I'm going to work through the reference angle theorem, so I'm going to find theta hat, right? I'm going to find that reference first by looking at cosine inverse of the absolute value of that ratio. So 0.7612. All right, and then in degree mode, I got my calculator in degree mode. I'll do that. Okay, I get approximately 40.4 degrees. All right, so that's the reference angle. Now we're in Q2, so let me go ahead and draw an angle in standard position terminating in Q2. So basically, have something that looks like this. Here's the angle I want. Now the calculator gave me the reference angle, which is the positive acute angle with the x-axis, so that's this angle. Right? So this is 40.4 degrees. Okay, now to find the angle that I actually want, notice the straight angle 180 degrees minus this little bit. So we have 180 degrees minus that reference angle. That should be the angle that I want, terminating in Q2. Right? So in this particular case, we have 180 degrees minus 40.4 degrees. And so theta is approximately equal to 139.6 degrees. Right? So that's my answer. Now I can go ahead and check. No need to check, but it's always good thing to check to make sure you got this thing right. Now, it's not going to be exactly equal because we did round off to one decimal place. So when I check here, I'll check cosine of what I think the answer is, 139.6 degrees, which is definitely an angle terminating in Q2, so that's good. And yeah, I get pretty close, so that's approximately negative 0.7615. So we're just off by round off error there, and yeah, that checks out. Okay, great. So that's an angle in Q2. Let's do another one. All right, so here we have tangent theta equals negative 1.8. Here we have a tangent. Doing the same thing, we're going to work through the reference angle theorem. So the reference angle is going to be equal to tangent inverse of the absolute value of that, so 1.8. Okay, so going to a calculator, at this point, tangent inverse of 1.8 is 60.9 degrees. All right? Once we know the reference angle, we can then look at our angle over here in quadrant 2, terminating in quadrant 2. Right? So this is the angle we want. And again, the calculator gave us that angle, so 60.9 degrees. So to get the theta that we want, what we'll do is take the 180 degrees and we'll subtract out, right, the straight angle, and then subtract out the 60.9, right, the reference angle. So the theta is going to be 180 degrees minus that 60.9 degrees. And so theta is approximately equal to 119.1 degrees. Okay? And then again, of course, you can go ahead and take that theta, plug it into the original, and see that it checks out. Now, it's not going to be exact, you're off by a little bit. It is round off error. It is rounded off to the nearest tenth, so you will have a little bit of round off error on your check. Now, for the last example, let's go ahead and look at secant. All right, for this last example, we have secant theta equals 2.5. Now, we're going to work through the reference angle theorem. It's positive, but we're still going to work with the reference angle theorem because we need to find the answer in the theta that's terminating in Q4. Okay, so we have secant here. Secant we know is 1 over cosine theta. And if we reciprocate both sides, we'll have cosine theta equals 1 over 2.5. All right, so the reference angle for this particular trig function is equal to cosine inverse of 1 over 2.5. Okay, so we can do that on a calculator and we get that reference angle. Okay, doing that I get 66.4, so theta hat is approximately 66.4 degrees. Now Q4, let's go ahead and draw that. We have an angle terminating in Q4, so looks like this. This is the angle that we're after. And the calculator just gave us the reference angle. So the positive acute angle made with the x-axis here is 66.4 degrees. All right, so in this particular case, we're looking at a full revolution, or 360 degrees, minus this little bit. So the theta that we're after is going to be 360 minus, the reference angle. Making the calculation, we're going to have to say 360 degrees minus 66.4 degrees. The theta that we're after is equal to 293.6. So 293.6 degrees. All right, so that's going to be the angle that solves our original. And of course, you can plug that in to check. We would say we want it to be 2.5. So we would say secant, or secant of 293.6 degrees equals 1 over cosine of 293.6 degrees, right? And then we can do that on a calculator. And I get approximately 2.5, rounding off, and that's what we had. And so there you go. We did one of each trig function, and we did one in each quadrant. And so that should be enough to get you going on these problems. So good luck, and I hope this helped.